Hello guys, welcome to Root and Route. This is Diljit here. This is my first video on this channel and is going to be a Rust programming tutorial. It's a course that I'm introducing, Rust CLI engineering from compile internals to concurrent tooling. For those of you who don't know me, I was running another channel called Alphas. Unfortunately, I had to close that channel due to circumstances and I lost almost all the content from that channel. So here is a restart for me. So if you were following that channel, or if you did like the content of that channel, we can consider this as the new place. You can expect the same content here. Even though I had to restart the entire stuff from scratch, but I will do gradually. I will make the video and all those content that I lost from the other channel. So come back to this course. This course is basically for anyone who loves to learn Rust programming, and this is not a course for someone who never did any programming. This is for someone who already did some programming and would like to explore Rust options. So if you ask me what is Rust, Rust is a system programming language as per their definition, but it's kind of general purpose programming languages too. And the importance of Rust is officially accepted in Linux kernel, and as per the latest news that came out, Microsoft is also doing the same thing. Microsoft is trying to rebase their code into Rust. I'm not sure. I don't know this officially it's going to be done, but Microsoft is rapidly accepting Rust as their code base now. So come back to the basics. Rust. If you want to install Rust, you can just go to this rustlang.org, and it has very clear instructions how to install Rust. And once if you install Rust, you can see this tool chain management tool is called RustUp. You can manage your entire Rust things using this one. If you want to update Rust, you can just say RustUp update, and there are so many other options there. We will explore those things gradually. And just come back here if you want to know where after installing Rust, if you just come here, you can see all these tools. Like this is a folder where you can see all the Rust toolchain tools are installed. You can see everything here. So just going back, let me check the presentation. I just made this just to confirm that I'm just covering everything. So these are the essential commands that you can just set up. And for information, Rust has 3 different options: stable, beta, and nightly. Stable is the one that is the default one that when you do the installation, it is the one that comes into your system. Beta is testing down for the next stable release, and nightly it will have almost every bleeding edge technical stuffs, but unstable features. You can use nightly for any specialized profiling or experimental hardware support. Means you can. A very good example for nightly is there's a famous eBBF library called IR, and IR is using nightly to make it possible because it needs more out of the box experiments to get things done in eBBF. So the other thing is the compiler pipeline. rustc is official compiler of Rust, and so what it does is it converts the .rs file to the machine code, but it's another tool chain. It's not something that is directly converting to machine learning code. It has a tool chain that that is producing different types of files in between. As an example, and these terms, if you're familiar with compilers and system programming, you will be familiar with these terms. If you are not, if this is getting confused for you, just skip this area, because it's just for your information how the things are done behind the scene. First, the sorry for that. First, the .rs file, the Rust code is just taken by the rustc, and it creates a AST layer where it's a structural representation of your entire syntax. Then it creates another intermediate level representation. It's called high level IR. Then it creates a mid-level IR, and the mid-level IR is a crucial step. This is where all the Rust specific borrow checking and other steps are done. Rust doesn't have any garbage collectors, so when it's generating the MIR, the middle level intermediate representation, it does check all the borrow, checker and ownership stuffs, and from there actually it is generating an LLVM-IR. The LLVM-IR is for the LLC, like the LLVM compiler. So then finally it makes the executable file. I don't know how to explain in detail about this one, because this is going to be more on system side stuff. But if you are interested, just try to explore these options. And the good thing about this one is you can easily create all these things that I will show you how to do that. Thus, compiler has options to do all these things. And these are the compiler options that is available. So you can make your own. Suppose if you don't want to make your code directly to binary file, you can create assembly code from the source file. You can create object file from the source code. Even you can create the other files like the LLVM-IR or the mid-level IR using rustc. So let's go and do some practical stuff so it will be easy for you to understand. So here I'm going to use a tool called Cargo. Cargo is the packet manager for Rust. So it helps you to create new projects, and even without using Cargo, you can directly create simple programs. You don't need Cargo for that. But it is really very helpful when you use Cargo if your project is really big and if you want to manage the project really well. You have to use this Cargo. So here I'm going to use the same tool, Cargo, and I'm going to create a project called just say basics. So it created the basic stuff. So I'm just moving to that folder and opening that. When you open that, you can see a folder called src, where you can see the main.rs file, and here you can see another file called tago.toml file, and this is the package manager file. And this one, cargo.log, I will talk about this one later. Now don't get confused on this basic stuff too much. So here I'm just saying welcome to root and route. I'm just saying this. So here what I'm going to do is I'm going to compile using rustc instead of Cargo. So what I'm going to do first is rustc. I'm just applying this main.rs file as our input and the Rust compiler converted that .rs file to a binary. Now it is there. So if you want to where it is, yeah, it is there itself. So I'm just running it. A is just printing the same thing like whatever it was supposed to do. So here the difference is that instead of I mean, we are now using directly the rustc as a compiler, not the cargo tool chaining. So the next thing we can try is how to use other options instead of the binary, how to make as an example, if you want to make assembly code connected to this one, some I think this is option. So if you do this one, you get a main.s file that has the assembly code for this one. So if you do check the code, you can see the assembly code corresponding to the program that we did, and you can see a lot of stuffs are here. And yeah, so you can see the exact assembly code that is generated by the compiler. So this is one of the ways you can create assemblies, and if you want to do an object file, we can create that too. It's called main.o here, and if you want to see the symbols on that one, I think you can just see, you can see what is happening behind the scene. And if you're interested more in the internals of this one, just try to go through all these different type of files and just see what it is offering, what exactly it is having. It will be really helpful if you play more with the rustc first, then move to cargo. So another thing I have to mention here is, now we know different types of how to generate different types of files. I mean, like assembly object files from the source code. Now what we are going to check is just how to optimize this using rustc. And if you see the main, you can see the size of is 3901144. So just imagine just imagine a scenario where you want to reduce the size of this file. You can do that using rustc, and this is the option for that one. So first we created first we generate a bulky file with all the debugging information, and just make the optimization level as 0. So there won't be any optimization, it will be a big file. Just try to do that. I think it will be the same as we have now, but let me try that one. I forgot. -G is for adding debugging symbols, -C opt level, opt level equal to 0. So now if you check, it's 3907688 and it was 3901144. Now it is 7688. That's a huge difference. So now what's the difference is that it will run, definitely it will run without any issues, but now it has more debugging symbols and other information, and there is no optimization, so the binary is very bulky. So now if you want to reduce the size of the binary, there is another option. It's called, you can create a release version from this one. You just use this option, the same thing, just remove the -G and set that optimization level as 3, and then you have to do a linger time optimization. It's called LTO. For that, yeah, it is -c again, LTO. This will definitely bring down the size of the binary if there is no syntax error. So now just run it. It will run without any issue. Oh, by the way, this is very simple program, so maybe for bigger programs you should be very careful about the optimization levels that you are going to use and other stuffs. But now if you check the size of the binary, see, it is dramatically reduced to 1793448, and here it was 390. That was a huge difference. So now we did the linger time optimization, and the optimization level as 3. So you can use rustc for doing all these stuffs directly without using cargo. And yeah, the link time optimization, that's all about this one. Now the next one, yeah, I already showed this on how to emit obj file and intermediate. I mean, you can try the intermediate course if you want. That intermediate representation of the .rs file. I recommend this to just to be familiar with all these things. I was just playing with these things and to be familiar with the concepts. And if you have that LLC installed, you can directly create rustc. You can use rustc to create an LLVM-IR file. Then you can directly supply that IR file to LLC to convert that to binary code. And this is another thing that you can do using cargo, the same thing. I will come to this one, yeah, but I can show you now. Now we already did on this one, so the next thing that we can do, but yeah, you can see the difference we are going to do here. I'm going to do the optimization here. What it's going to do is it's going to create a profile for me for the release build, and when I'm going to use cargo to build this source file in a release mode, this part is going to take effect. So let me show you that. And regarding the options, it says optimization for size is Z, and there's an link time optimization set, and panic abort. If you don't worry about the panic abort now. What it does is actually it removes the stack unbinding code, and as per the documentation and other stuff, it just saves at least 100 KB plus size. And yeah, is stripping all the debugging symbols. So this should work for us, and let us see how now it is. You can see the difference here when you are using cargo with the level Z. What is going to happen is cargo build hyphen release. So it's building. Now the cargo is using rustc to make the option for us. So now if you see, there's a new folder created here. It's called target. Under target there is another folder called debug. Inside that actually where is the binary? What, did I miss something? Devs build. Oh, sorry. It created under the release mode. We use the cargo build release. It should be here. Where is it? Yeah, it is basics. Oh, I was searching for the main. Okay, this is okay. When we are using cargo and when you build it, actually, it's not going to create a main dot binary or main dot or main dot, nothing like that. It is going to create a binary based on the name of the project. Here we use the name for the project is basics, so it created this for us. So let us okay, let us check for target release -L. See here, you can see the basics is created, but it didn't change much here. It may be because of the optimization level we use. You could change this to 3 and try again. But what I see normally when using this one, it doesn't make much changes on this one here. See, I think it's increased now. Previously it was 3054, so G is the most optimized level for when using with the cargo. And you can see all this documentation inside the site. If you have any doubt on that, you just go and refer there what are these optimization levels and other stuffs. And for next, regarding the compiler internals is okay, yeah, that's about the compiler internal stuffs. The other thing you should be familiar with is rustc. Target list will give you all the supported platforms, and see this is on that is installed now. And if you want, you can install any of this using rustc install and just give the name of this any of these stuffs. So if you want to build Linux binaries from the Linux, you can install this one and you can build the binary from here. Just mention the target. So we'll be doing all those stuffs while going forward, and I'll be introducing more cargo options and more rustc options. These are the basic stuffs you should be familiar before you're trying to do any more programming on Rust. So the next big thing about Rust is, I don't know whether I mentioned this one before, Rust doesn't have any garbage collector. It is using its an operation model called ownership and borrowing stuff. So at any given time in Rust, there will be only one owner for any specific variables or any specific values in memory. So as an example, when I say, so I'm going to convert this to a variable type, and whenever in other languages when you declare some variable, it is not, in some languages it's not immutable by declaration. Example C, when you declare some variable in C, it is mutable. You don't need to mention explicitly it is going to be mutable. It is mutable in C. But here in Rust, as an example, when I say welcome, I'm going to take this one. Here. So you can see the Rust analyzer. Oh, I forgot to mention one thing. Once if you install Rust and if you are going to use this code, VS Code as your code editor or IDE, you have to, it's always better to install this one, Rust analyzer. So Rust analyzer will be really helpful for doing helping. I mean, like it's like an IDE integrated stuff. So you don't need to be much worry about the syntaxes and other stuff. It will highlight all those stuffs for us. As an example here, when I was doing this one, it is showing that it's the data type of this welcome is an ampersand str. I will come to this what is ampersand str. So what I was trying to say is, also sorry for changing this one, I can't show you the example with using this one. Instead I'm going to use another type called string and from method. So yeah, why I'm going to use this one is I have to show you the ownership stuffs in Rust. So now we have a variable called welcome and it has a message. So, and this is type of string. This is not the ampersand str. I will tell you the difference between these. So now this welcome string is created in actual string is created in heap, not in stack. That's another thing that you should be familiar when you are working with Rust. Don't worry about that, it is here. So what happens when I'm declaring a variable as a string in Rust? So a string in Rust is going to be having values in stack and heap. The actual string value, the continuous array of characters, is going to be created in heap, but a pointer to that heap memory, the starting of the memory means index 0, is going to be created in stack. So just as an example, instead of s1 here my variable name is welcome. This welcome will be created like this in stack. It will have pointer, it will have a length, it will have capacity. We'll talk about length and difference between length and capacity later, but just imagine capacity is somewhat kind of length, but it has a different meaning. So the pointer is nothing but a pointer that points to the heap, start of the heap for this string. So that's a connection between this string, the heap value, actual heap value, and the variable name. This is how a string is allocated in Rust. Don't get confused. This is entirely different from other languages. I think most of the languages, because when you are trying to declare a string as a string type, it is having two parts, one stack and one heap. The heap is holding the actual string, and the stack is having a pointer to the string, start of the string. So the ownership is handled in this way. So imagine you have a string called s1, or just say welcome 1, and I have this as the welcome message, and when I'm going to create another variable called s2, let s2 as equal to s1. So what happens is I'm just moving the ownership. Moving the ownership means after assigning s1 to s2, s1 will be nullified or invalidated. There is no way to use s1 after assigning the value to s2. I'm not, maybe it's confusing for you initially, but just try to do that here. So now I have a variable called welcome, and as I said, it's basically when you are declaring a variable normally without mute keyword, it is immutable, so you can't do anything on the variable. So suppose imagine you need to add some new stuff here. Welcome to root and route by alphas. If I do this is going to be an error. Why? Because my variable is not mutable. But if I do this one, you can see that error is gone, because now I can edit changes on this variable. I can add values to this, add extra values to this variable, so I can do any kind of editing on this string. So now the string is value is done, but imagine let new welcome message equal to welcome and print if I want to print the welcome here, it already shows the error here because C is a borrow of moved value. Why? Because when we created a new welcome message and assigned that to the previous value of the welcome, what happened in memory is the same thing. So now initially the welcome 1 was pointing to here on the heap, and when we assign the value, is any this is better. When we assign the value welcome 1 to the new welcome message, the pointer to this heap memory is moved to here. So the S2 is pointing to, the new welcome message is pointing to the heap now. So this part is nullified. So this can't be used after the assignment. That's called ownership moving. Moving the ownership between variables. Maybe initially it will be confusing, but the better way to do that is just make mistakes and learn it from that. If you do this one directly instead of build, I'm going to run it. So it says if you want, see the value borrowed here after move. You already moved this welcome to this variable, and again you are trying to reuse the welcome. So it won't allow, the compiler won't allow you to do that. Most of the time the compiler messages are really helpful. So what it says is if you want to do that, you have to do a clone of the stuff. So if I do a clone of the welcome message, so here it is actually creating two stack pointers. It is here, in fact. I think this is a clone part. This is a copy part, we are moving the stuff, and this is the let me check. Yeah, this is the same thing that we were trying to do. We just assign the value and trying to print this one. It is showing this error. If you heard about, these terms you don't need to much worry about now. When you're doing a clone, actually it is doing a deep copy, means it is creating an entirely entire stack content to the new variable type. Means this is not the one that we are looking for here. This is okay. I will explain this with very simply, when you're creating a clone, that means it's going to create an entire new stuff for you. Like it's entirely a different welcome. string that the stack is pointing to, and the entire stuff is completely different. There will be two copies of this one now on the stack and heap, so it has no connection. So you can reuse this. So if you, after cloning it, if you try to run this, see, it's absolutely okay to use that, because these two things are entirely different now. Welcome is not moved its ownership to new welcome message, and it is complete and entirely different, and you can make use of that. That is one of the rules that you have to follow when trying to play with the ownership stuffs. And there are other ownership things that you should be familiar with, and this okay, just imagine there's a function called function print welcome, and just let it be like WLC, and suppose if it's a string, and I'm just copying this one, just say WLC here, and what I'm going to do is I'm going to call the print welcome message here, print welcome, the same effect, like if you got confused with the println, the same thing is happening here, welcome, and just comment this one. See, the same thing is happening here. This another way of just doing it. I think it will be more clear for you now, instead of just showing the println. So here I'm just passing this welcome to here. When I'm doing that, actually I'm moving the ownership from welcome to WLC. So after that, once it's moved, I will never be able to use welcome again. So if I wanted to use that, yeah, definitely I have to do the clone. So it will be another copy of welcome. Then you are free to use that. So there's another way of doing it is called references, and yeah, we will be talking about that on coming classes. So this is the very fundamental rules of ownership. You can have only one owner at a given time for a variable. It won't allow multiple owners. There's more advanced part on that one. Definitely we will cover all those things when we are covering this Rust CLI engineering course. So what else is there? Yeah, there are, as I said, this string type is created in stack and heap in Rust. There's another type called let name equal to this type is called &str. It's a slice, or you can call, yeah, it's a slice of string, and it's always immutable. And the best part of this one, it's not the best part, but suppose if this is a string like this, and now if you call this one here, name, and even after passing that here, I can use that it here. You know why? Because we are not actually transferring the ownership to the new function. We are passing a reference of the variable to the new function. So when you are passing a reference to a variable, it is not moving the ownership. Instead, it's borrowing the ownership. So it is like you can use this variable and do the operations and just give it back when the operations are done. That's what happening here. So if you run this one, it won't make any issue. See, it prints 2 times even after passing the variable to inside this function. Why? Because we just did a borrowing stuff. It was not the actual ownership movement. This is a major difference between the borrowing and moving ownership of variables. And don't get confused, it will be easier for you when you are trying to do more programming based on that one. So I think that's all about the basic stuffs. Yeah, these are the things that you should be familiar with, and all the primitive data types including integer, boolean, float, characters, everything is going to be allocated in stack as a raw value. And when it comes to string type, it is on stack and heap as I shown. It has a pointer on the stack and the actual value is going to be the heap. And these are the types inside the stack for a string. And str is always be on the stack, and it kind of pointer, length, and that points to the existing data. And vector is another type that is actually on the stack and heap, and yeah, definitely the data is going to be just like the string type. The data is on the heap, but there's a pointer from the stack to the heap that help us to interact with the vector. So that's all the fundamental ownership stuffs based on this one. So what I'm thinking is to try to create a project that will help you to do more stuffs on this one. Based on the stuff that we learned, and just to learn some more additional stuff, we will try to create a project. I actually did the same thing, same kind of project on my previous channel, the Lost channel content. But today we'll be trying to do something different in a different way. Okay, just say cargo new password validator cd I'm just opening this. So what we are trying to do is we are going to create a CLI app that, okay, we can try the first app, let it be like let us accept the user input. Then while doing this project, we will be learning a lot of new stuff, so it will be easier for us to implement and learn stuff, so instead of exploring all the Rust features. So what we need basically here is we need a function, just prototype like validate, say validate password, and let it be like psw and a string slice. What can be done? I think the previous lost content video I created something that was mentioning strong password or not, something like that. It was a string type return, but here we just make it an integer type. Why an integer type is just is going to return a score of the password that is passed to it. So let it be there. Okay, just say a variable here, mute score equal to just, and okay. In Rust, actually, you can either use the return keyword to return a value, or you can with the semicolon, or you can just say score without a semicolon, so it is automatically considered as a return type. But I strongly recommend to use the return keyword otherwise it will get confused. I mean, Rust has a pattern like that. If you are interested in that, you can make use of that. Now what we need is we have to accept the user input. So there's a macro called just like print ln. There's a macro called print, and you just say enter password or something, password to validate. And it is not like C. In Rust actually you have to do a bit more work when you are working with this one, especially when you are using print macro. You have to do an std out flush I think this one will work. Why we are doing this one is most of the time if you are not going to use this one, you won't be able to see the message, the enter password to validate. That's you have to explicitly do stuff that not as simple as C, printf and scanf. See, when I use this one, you can see a use statement here. Here we are mentioning that we are going to use stdio. And what the self means, self pointing to this one. If you are not going to use a self, what you can do is you can put a semicolon here after the IO. Then you can say on the next line without having self, you can say write in 2 lines. Instead of that, you can write in single line. Just refer to itself and the write. So now we have now we are asking the user to enter the password. So what the next thing we need to accept the password. It is similar to scanf. It is very easy in C to do the scanf and just send that to a variable, but it is not inherently secure when you are using scanf in C normal way, because it has memory leak, other stuff issues. But nowadays actually the compilers are really better. So but for this one, as we know, when the input is going to be just say input, and it's going to be in string type. This way of creating new string like this, and it should be a mutable string because we have to because we are updating taking the value from the user at the time of the program is running. So the variable should be mutable, otherwise we can change. And just like any other languages, you know, this is entirely a very big line to read from the keyboard. Just like we flushed the std out, here we are going to use the std in, and there's a function called readline, and the readline is accepting a buffer. We have to mention the buffer name here. And if you see the readline method here, you can see the readline is returning a type called result. Result is another fundamental stuff in Rust. It is really helpful when you are returning some values. Result is actually an enumerator enum that has an OK or error type. So it should either return an error or OK. So when you're doing the read line, you should handle that error. The best way to do that is here. Either you can do an unwrap here, but sometimes what happens with the unwrap is unwrap, if the unwrap fails, actually the entire application will get panic, and it will end up in a mess, in fact. So the best way to handle that is either you can handle the result explicitly by checking it, that we will do later. we'll be covering the result type in detail. Here there is an effective way that is called expect. So what we can do here is expect read error from keyboard. So what it's going to do is, if it's going to fail, instead of the panicking when you're using unwrap, it's going to say, yeah, still it's going to be an error and panic, but it will clearly say this is the error of this part of the program is creating error. So it will be easy for you to debug and find the issues. So now we have the user entered in value inside the input variable. So let create another variable. Let say password. Can say password or pw. Okay, just say password equal to input. There's a method called trim that will just trim out all the unwanted options, unwanted stuffs from this variable, like the /r, /n. I mean the new lines and other stuffs will be getting trimmed off. I'm expecting that. I'm not sure. It will remove all the white spaces and new lines from when you are using trim. Let us see if it's not going to work. There may be some other trim method that will help us to do that. So now we have this one, and let score equal to validate password and password. So here is the another thing another thing in Rust is, actually Rust is supporting with a lot of built-in methods and closures, and if you want, you can make use of the closures or my built-in methods to help you to iterate over the strings, iterate over characters inside the strings. But here we are not, I didn't introduce you to the closures or any other stuff. So what I'm going to do is in manual way, just like the programming way that we do it in C or any other languages that doesn't have much iteration options inside the string. So what we can do here is, now we have the password here. So you have to, okay, before iterating over that, you have to declare some other variables called has upper equal to true. Let it be let mode has lower equal to true. Sorry, you have to, if you set it true, it will be confusing later. So I'm just saying there is no lowercase and no uppercase. So now we have the variables that is going to check for us. Actually, you have to add more stuffs like has special character, has digit. No, I think instead of one upper and I say digit. See, it should be in a real time, and in a real time implementation, it should be uppercase, has digit, has how to say special characters, and the length. Everything should be checked at the time, yes, in a real time. Just for the demo purpose, because we are not going to use the Rust built-in functions here. I'm just showing how can we achieve that, just to be familiar with the Rust programming stuff. So what we can do is, the next thing that I can say is say all the bytes from the password. So we can say psw dot I think bytes, not bytes, yeah, as bytes. That is going to return an ampersand u8. Okay, that reference to an array. So I think this will have all the bytes of the password. So the first thing you can check is like if the password length, like bytes of length, I think bytes like this. No, it should have length, right? Length, yeah, byte of length greater than equal to 12. If that is the case, you can say you can increase the score, it's equal to 1. These operators are same like C and other stuff. It is nothing but score equal to score plus 1. It now the score is, I mean, one of the criteria is matched. And for the other one, instead of using Rust common built-in functions, we are going to iterate over what to say, I or any variable that you can use. 0 to, this is a way you have to get the range. Why I'm introducing all these stuffs, because if you're going to use that was actually a mistake that I did on the other channels, the lost content. I directly used Rust built-in functions instead of manually doing stuff. Definitely the built-in functions are more performance oriented than this one, but when you're using these kind of function, I mean these kind of options, we will be getting familiar with other Rust options, like how to iterate over a range of variables, I mean a range inside the array. So here we have to iterate over the bytes. So I'm just saying now we know how to get the length of the array. So now we are iterating over all the characters. Now what we do, take individual bytes. Okay, byte, okay, just a byte equal to bytes of I. So now we have so here the better part is like now we have the actual byte. So here we need to check whether it is going to be an uppercase or digit. So I know the ASCII values of this one, so yeah, normally I do this very frequently in C. So I basically here you can the byte is going to give you the actual value, ASCII value of the characters. So for the capital, I mean the uppercase one, it is like between 65 and be less than 90. If this is the case, actually you can say it's has upper equal to true, and the same thing like for digit. I'm just copying this one. For digit, actually it is between 48 and 57. Don't get confused on this part, like I'm really familiar with all this ASCII value stuff, so that's why I just checked it. There's another way of doing it. You try to explore the built-in functions of Rust. I'm just showing you how to do the if checks and for loops in Rust. So that's why I'm just trying to use all this manually. And here it is not upper, here is going to be digit. So now we have Is any error? Less than. What is this error it shows? Oh, no. It's byte, it's not B. See the shortcuts always. So now, and one more thing, this is, as I said initially, this is not going to be a real one that you can make use of in real time. What we can do is just convert this program to use built-in functions of Rust and add more functions, like whether it has a special character existing inside the inside the string password, and add more values, I mean like more criteria to get the score. So here, after the for loop, suppose if has upper, then the score is, we are increasing the score again, and the same thing here. So now if everything is done, like if it has, we have only 3 criteria here, I'm just trying to wind it up because if I continue this one, it may take more, it will be a very lengthy video. So what I'm going to do here is if this there's an upper or digit, then we increase the score and return the score. So what what here we have to say, we are validating the password, we are getting the score, and instead of score we can say strength of the password. I think that is more meaningful. Strength, password strength, and println just say strength GTH. Spelling is wrong here. Strength of the password, and we can say GTH strength. What should be we say? Out of 3. Yeah, now it is out of 3 because we have only digit, the length and digit and uppercase. But I'm saying again, if you want to do it, just change the program in a way that you are checking the the special characters too. It's easy to check it here. It's like just check the ASCII of this one and just ensure, and one more variable has special character. If that is the case, just increase the score and just make it here as 4. That's it. I'm just leaving that to you, so you can try to do that. So now I think now we learn how to, if everything works well, we just learn how to use another package like IO, and how to receive user input and save it in a variable, and yeah, basically pass. I'm like, here we are just here is ownership stuff. Here we are doing the borrowing rule, not the moving ownership rule, because we are using underscore ampersand str. So just cargo run, try that. 1 2 3 4 5. The strength is just 1 because it has only a digit. Cargo run A B C, because it's 0. Definitely. Why? Because it doesn't have any uppercase. We are checking uppercase, digit, and the length of the password. So just try one more. ABC 1 2 3. Now it is 2 because the password length is less than 12. So try the other one. So here we say ABCD 2 3 4 5 6 7 8 9. Just add more. See, now the password strength is 3 by 3 because as per our current checking, we this password is satisfying the uppercase digit and the length of the password. So that's all for this video that I'm planning. If I continue this one, it will be really confusing for you. You just try to learn this basic stuff and try to do more programming. The next application that you can think of doing this one is do a password generator. Anyway, I will show you how to. We will do that on the next project, just to be familiar with some more stuffs. So there we may be using other options, like instead of take the password from the user from the keyboard, we can try to take the password from the command line argument. So we will be doing that on the next module, and yeah, definitely we'll be doing more and more projects. I will try to focus more on the security projects. That will be more interesting for me too. So that's it for this video, and we'll be continuing this Rust CLI engineering course till we do some very interesting big project. So that's all from my side for this video. We'll be continuing this very soon, and if you are interested in this kind of stuff, and yeah, definitely there will be more security stuff coming up, especially on malware development using Rust and eBBF programming, Linux internals. Actually, I planned a lot of for this new channel. I have to make it up and running just like my other one. The other one I didn't get enough time to do videos, and I was getting delayed in between videos, and finally some of the videos got issues from YouTube because of the content, and yeah, it had a lot of issues. So yeah, that's it from my side. It will be soon. I'll be soon coming up with the next part of this video. It won't be too long. Just wait and watch, and if you are interested in learning Rust, just stay here, subscribe, and just support. That's it.